So what went wrong for problem number 6? Now, it's asking me to find the sum of these terms when x equals 1. And basically, what I think I did wrong was I used this instead of using this to find the sum, which is like why I got like this instead of like getting a negative 3.6. Okay, let's begin at problem number 6, which is finding the sum of these terms when x equals -1. Okay, we're going to first start off this problem by finding the series for this terms, which now this kind of reminds me of this, which would be x to the 1. I mean, e to the x, and the summation of this would be 0, so there's xn over n factorial. Now, it reminds me of this, but it's not that. Now, we could find it by doing a different way of approaching it, which would be like doing the top first. x1, x2, x3, x4. Now we do the top first, and we know it begins at 0 to 1 to 2 to 3. So we can notice here that x1 is, they all are 1 more than these, so we do x plus 1 for the top part. And the bottom part, I think would be just, let's see, it just matches with this, so I don't think we have to do much. Just x into the factorial. And now we found the summation of it, which has to begin at 0. Okay. Now there's a problem here, which is a lot of students would like to do is just putting it into their calculators and trying to find the answer for it. Now, this approach, you could do that, but at the same time, if you get it wrong, you're kind of like, it's not good. So a better way of approaching it, which would be removing the x from it. So this x to plus 1 equals this xn to 1. Now, this is just simple algebra. You could remove the x from it because it's n plus 1, which would be like this. These equal each other, by the way. So if this equals each other, we could remove the x from it, from the summation, which would be x to n factorial 0. Now these are equal to each other, so, and we know what this entire summation equals to e to the x. So a better way of writing it would be like this. Now we could just plug in -1 for the x, which would be like this. Now we get 1 over e. And now, let's see what equals to. This would equal to about negative e to the, 3, 6, 7, 8, 7, 9, which is just this. So that's how you do this problem. A lot of students would mess up by plugging in x to the n plus 1 over n factorial, which is what I did. And you can do that, but you're not gonna get the. It's gonna be like your calculator isn't gonna compute it. So a better way is just removing the x from it and substituting e to the x for the summation down here. Get e to the x, and we just plug in -1 for the x, so we just get this answer. Let's see. Which is the right answer, and that's how you do problem number 6. Okay, problem number 1. What I did wrong was using the wrong test. Now for mine, I try to use multiple tests to see if it diverges or converges. But the issue was that I used a root test, and instead I should have used a comparison test, which would be just a better test to use for this problem. Now we're gonna show you why you shouldn't use a okay, fuck. Okay, let's begin problem number 1, which would be question, I think it's A. Okay, determine if the following converges and if possible find the sum. Okay. Now, let's see here. First thing you should do is use the test of divergence, which would be finding the limit. Limit goes to infinity. 3n plus 1. Okay, now let's factor out n to the 3. Would be 2 to the 3, 2 to the 3, 2 to the 3, 3. Okay, now we get 5 plus 3 and 3. Get 1 over. Actually, wait. It's into the 2. It's going to be cleaner if we do it this way. Into the 2. We basically have this plus now remember here we're trying to find the limit, so all of these would go to 0 because the bottom is n squared, so this would be 0, 0, 0. So we get this, which would just give us 0. So the test of divergence basically, it doesn't really tell us that it converges if it equals 0. It just tells us that we don't know if it diverges or converges. So we have to use a different test now. Now the test you should use when it's like this is a limit, not a limit comparison, but a comparison test, which would look like this. 2n plus 1. Now we're going to compare it to one that diverges, which is 1 to the n. And if this one is bigger than the one that diverges, then this one has to diverge as well. So we're going to see if it does. If it is bigger, we have to multiply this out, which is which would be like this. 3n is 1 is bigger than n3 plus Okay, let's. Hmm. Okay, now you could factor out even more to see if it's bigger, but here we could tell that this one is absolutely bigger than this one. And we could see. Hmm. Could factor out -3, but I think this one would just remain bigger. So, so based on the comparison, this series, and that's pretty much all. See here, we basically, the first thing we have to do is do the test of divergence, and we got 0, so we have to use a different test now. And now the test we use is a comparison test to. Now this one diverges for sure because P series. This one is 1, so it's just gonna diverge. And if we compare it to this function, if I mean not function, but this series, and if this series is bigger, it's gonna also diverge based on the comparison test as well. And we know this one is just bigger because you could just plug in 1, and this one is gonna grow a lot bigger than this one. So we just know based on the comparison test, this series will diverge. So yeah.